Can you guys hear me okay?
Yep.
Perfect. Welcome everybody to the last meeting of 2019-2020 ASHRAE Toronto chapter. So thank you everybody for joining us here today. And we have a very special presentation for you today. We have the Epidemic Task Force, which is the body that ASHRAE Society has put together with experts from around the globe. And they have been coordinating with different groups and putting together guidelines for how we should be operating buildings. So, which ties into our topic today of how the future is going to look like, how COVID is going to impact building design and operation. So we'll, to start off, we'll go through some housekeeping items. So Jamie, could you please put the slides on?
They should be on. Can you see them? You can't see them?
I can see them.
Abby, can you see them?
Yeah, I can see it.
Okay, here we go.
Great. So first and foremost, as always, we would like to thank our sponsors, because of who we are able to keep up with our donations. ASHRAE Research, all the money goes to ASHRAE Research in Canada. And again, big thank you to our silver, gold, platinum, bronze, and nickel sponsors. And again, as the new 2020-2021 year begins in July, if you would like to volunteer with us, please reach out to any of the board members, and we'll get you connected to the right people, and we'll find opportunities for you. Personal experience, it has been very rewarding, so highly encourage everybody to do that. Next slide, please. So this is something that you're going to need today, so please pay attention if you haven't been so far. At the bottom, there's a Q&A tab of your Zoom window. So any questions that you would like to ask us during or at the end of this presentation and panel discussion, that's how you're going to do it. And again, it's at the bottom of your Zoom window. It says Q&A, and you'll be able to ask us all the questions then. Next slide, please. So quick update again, since just like everything else has been canceled because of coronavirus, so has ASHRAE Summer Conference in person. But what has happened is we've moved it to a virtual conference this year. So what that means for you is that now you don't have to worry about traveling all the way to the States and attend the conference in person, or you don't have to miss out on the opportunity to attend the conference. You can just do it from the comfort of your home. And just like the conference, the technical committee meetings are also virtual, and they're going to be free to attend. So, but the conference and other presentations are paid. And this panel today actually is going to be a part of the conference as well, and it's going to be a live panel at the conference level too. So you're getting a scoop of that right here with ASHRAE Toronto. Next slide, please. So at this point, if you have been attending our last couple meetings, you know this is becoming a regular thing. We've got Kara with us, and she's going to share the main issue of the ASHRAE journal. So tune in to see what she has to say. Kara, off to you.
Kara, you're muted.
Not only am I muted, but I'm not allowed to share my screen because the host has disabled screen share.
Oh no.
I know. Hi guys, my name's Kara Sloat. I'm a consultant who works in new and existing buildings, and I work out of Toronto. And
okay, try now, Kara.
Perfect. This session is the way that I keep myself accountable to actually read the ASHRAE journal every month. So I hope to inspire you to do the same. This month, May 2020, was primarily COVID related. So the majority of the content I'm going to be summarizing has to do with ASHRAE's guidance on COVID, and we're lucky to have a lot of the people who are much more expert than I am here to answer our questions. I'm also including some small amount of non-COVID content to keep our minds fresh and distracted with all the other great stuff we used to get to care about. So things in this journal article included Standard 90.1 2019, a discussion of the new standard. A second part to the feature that I described last month on how stack pressure creates airflows inside the insulation in passenger aircraft, which is a substantial source of energy loss. Two technology features on high performance ambulatory care facility and a Kentucky high school. A feature on counting carbon, so embodied carbon, and the circular economy, how it applies to mechanical systems. A feature on refrigeration, getting the best from zeotropes. A feature on how to improve surgical theater design using coupled CFD multi-zone software. A research update on the effects of airside fouling on condenser heat exchangers, and advice on insulating concrete foundations. So I'm going to feature 3 of these discussions, all of the COVID and the carbon and research updates. So starting with the research update, this was short but really interesting. In this study, researchers collected field fouled residential air conditioners and tested them in the lab. They used what they'd actually seen on those condenser coils to create a equivalent fouling material for future tests so that we can better represent what happens in the field when we test these coils in the lab. They also found that these coils actually performed better when fouled than when they were clean. They speculate that might be because of turbulence, but about 50% of the coils they tested actually improved their heat exchange. So if you want to know more, have a look at the article. The Carbon and Circular Dynes article by Erin McConaughey flagged the fact that mechanical as a discipline is lagging behind structural and architectural disciplines when we consider embodied carbon. So many high performance mechanical systems in low carbon buildings have higher embodied carbon than the standard efficiency mechanical system would have. So the article challenges all members of ASHRAE to consider life cycle carbon economics as they're designing buildings, and described a couple of models for using both reduce, reuse, and recycle principles, as well as principles of circular economy to improve design decisions and reduce the total carbon associated with the buildings that we build. Finally, there were 2 features that had to do with COVID in the journal. The first was a industry feature on the ASHRAE position document on infectious aerosols. The COVID-19 statements that our organization has come up with are that transmission of SARS-CoV-2 through air is sufficiently likely, that airborne exposure to the virus should be controlled, and that ventilation and filtration provided by HVAC systems can reduce airborne concentration of SARS-CoV-2, and therefore people should not turn off their HVAC systems. There are dangers associated with unconditioned spaces that are higher than the dangers of circulating your HVAC system. So in addition to that, they advised that while existing code and good practice remain the minimum standard, it's reasonable to consider enhanced measures to be even better prepared to control aerosols in every design, to use an integrated design approach to infection control, including the whole design and construction team, that designs that promote cleaner airflow patterns are always advised and supported by high quality research, and that for healthcare and high risk facilities, there was substantial additional guidance, and you can refer to the document for more details. They also provided evidence-based mitigation strategies, which can be applied by professional engineers on a case-by-case basis. Strongly recommended with good evidence were enhanced filtration, upper room UVGI, and local exhaust ventilation. Recommended with at least fair evidence were personalized ventilation systems, portable freestanding HEPA filters, and temperature and humidity control. There is quite a bit of information about what those targets should be, and we can ask our expert panel more questions about that topic in particular. For existing buildings, there were specific measures recommended increasing outdoor ventilation where outdoor quality permits, disabling demand control, opening outdoor air dampers to 100%, while keeping in mind that maintaining temperature and humidity is also important. So you need to balance those two things as the temperatures become more extreme. Improving filtration at least to MERV for 13 or max possible, sealing the edges of filters to limit bypass, running systems 24/7, considering bypassing ERV modules if they're permitting unfiltered air to bypass filters, considering those HEPA filters, and considering UVGI. Further guidance, if you're advising existing building owners, was to clearly communicate that risks can be reduced but not eliminated, that any advice is building specific, to tell them specifically about the limitations of their HVAC system, to be clear about our state of knowledge, about the virus and its transmission, and about the importance of addressing physical distance, hygiene, and personal behavior factors in addition to addressing the HVAC system. ASHRAE.org/COVID-19 has all of the latest guidance from our organization, and we have free access to the handbooks until June 30th to support you in working from home. So that was the last really great thing I found in the journal that month. Thank you very much. Let me know if you have any questions.
Great. Thank you, Kara. So all our COVID-19 questions have been answered, right?
That's just giving you the baseline.
Just got to read.
Just exactly. Okay, great. Next slide, please. So what we'll do here is we'll get started with some introductions about the panel. So on the panel, we have Luke Leung, Max Sherman, Michael Sheeran, and Kyle Hassencox. And I'll be moderating the panel, ASHRAE Khurana. So we'll get started with the introductions of the panel once we change the view, and now that's that. So let's get started, and to make things easier, we'll just go in alphabetical order. So let's start with Kyle, Luke, Max, and then Michael.
Hello, my name is Kyle Hassencox. I work with Rocky Point Engineering. I'm out of Victoria, BC, Canada, and I am on the schools team. With ASHRAE, I'm involved in various technical committees, including being current chair of ASHRAE TC 97, which is educational facilities. I think that's about it.
Hi,
Thanks, Kyle.
my name is Luke. Yeah. Hi,
Yes,
my
continue,
name
Luke.
is Luke Liang. I'm from Chicago. I work for SOM. My home is, well, my second home is in Toronto, and I am on the ASHRAE COVID-19 task force in a commercial building, also vice chair of the Environmental Health Committee.
Thanks, Luke. Off to Max.
Yeah, hi, I'm Max Sherman from the San Francisco area. I'm on the Epidemic Task Force, and I lead the residential team.
And hi, I'm Michael Sheeran. I'm going to bat cleanup, I guess, today. And if we're doing baseball at all, we'd probably do hockey instead, sorry. But I'm the CEO at TLC Engineering Solutions in Orlando, Florida. And I'm also very involved in ASHRAE from being the chair of ASHRAE Standard 170, which is ventilation for healthcare facilities, and chair of 189.3, which is the design, construction and operation of sustainable, high-performing healthcare facilities, and have been involved on the healthcare side with ASHRAE for many years.
Thanks, Michael. And again, as I said, I will be moderating this session. My name is ASHRAE Khurana, and I'm a controls contractor here in Toronto. And let's get started here. What we would like to know before we deep dive into the questions, guys, is tell us a little bit about ETF, the Epidemic Task Force. What what do you guys do? What kind of collaborations do you have? What were the lessons along your journey from the beginning until now? And how has your advice changed along the way, if in any way? Maybe we could get started with Kyle again.
Sure. Well, the Epidemic Task Force is a group that was put together of experts in each of the different areas. The idea being that they contacted a lot of the technical committees and asked for kind of volunteers that might be interested in this. And I think for the most part, a large number of us, based on what was going on, we said, yeah, sure, we'd absolutely love to help. Because it seems like the built environment is playing a role in this, and therefore, we want to do what we can to try and help. I think that Michael can probably comment a fair bit on the coordination with other groups, but I know that there's been coordination with a lot of different groups, including there's some stuff with the CDC and some of the researchers that are going on out there. I know I've read a lot more white papers than what I might care to normally.
Yeah, we're becoming a lot more adept at reading research, just because we're trying to glean as much as we can, as soon as we can, to better appreciate and understand what should we know, and how is it going to help us better advise folks. I think we've all read a lot more pre-publication, meaning that's research that's just come out. It hasn't even been fully peer reviewed, but anything you can do to kind of glean more information is great. We were really, ASHRAE's done a really good job of putting that ETF group together, because beyond healthcare, every space type at this point, is trying to figure out the best answers, and us as advisors and consultants trying to provide the best answers to owners and operators of facilities all over. We were really at the front end on the healthcare side, primarily just because they were going to be the facilities that had to take the brunt of supporting and being prepared for patients. So, that really kind of set a little bit of the tone for what we could do. We worked very closely with ASHRAE, which is the American Society for Healthcare Engineering. That's also the co-sponsor of our Standard 170 and Standard 189.3. And I would also, encourage, if you're dealing with healthcare facilities, there's also a lot of really good information that is on the ASHRAE website, in addition to all the stuff that ASHRAE has aggregated, which is a reflection of the work that we did together.
Yeah, I will echo that on the commercial team, because the information is not just in US. We also reference that from the European RIVA to the Chinese, Asian, and Hong Kong, some of the guidelines and what they went through. And also some of the information is from Biodefense Council in US, about Defense Department in US. So hopefully we can touch on some of those.
So to give a little higher level view, the ASHRAE Board of Directors, or actually the Executive Committee, decided that ASHRAE needed to have a very rapid response to the COVID problem, and decided to create the Epidemic Task Force with sort of the ability to react quickly, faster than, I guess, what we all call the speed of ASHRAE, because we know that things were going to happen quickly here. So the task force itself has about a dozen volunteers leading it, then a bunch of staff and some executive officers who interact. And every one of the volunteers is a head of a team. And then within the teams, there's a bunch of technical people who help actually create some of the content. The structure of the task force, or should I say the charge of the task force, was not just to do something very quickly, but to do something that would put ASHRAE ready for not just this epidemic, but the next one. So that's why it's called the Epidemic Task Force, not the COVID Task Force, because while the immediate response has been very COVID focused, the task force is hoping to move the society in a direction so that the next epidemic, we won't need a task force because we'll be somewhat prepared. So the charge of the task force extends to creating research, to creating groups, to changing our long-term guidance, our standards, our research, whatever it takes in order to have recommendations ready for the next time there is. But right now, we're focusing on this time. And so the immediate focus of all the teams was, what can we say today? Let's say it quickly. And then let's start revising that as needed and expanding that as needed. So that's sort of the overview.
Makes sense. That's great. Thanks for answering that. So now that everybody has an understanding of what ETF is and what ETF does, we'll segue into our next topic, which is, and I know that most of the buildings are at the verge of opening up at this point, but let's not ignore the buildings that are still closed. Let's take a couple minutes and touch base on the buildings that are still closed or partially occupied. So how should these buildings be operating at this point in time? And I'll open up the floor. Kyle, I keep picking on you, alphabetical order. So let's do that again.
Sure. Well, it's basically that I know that was one of the first kind of tasks that were really set down on is that at some point they're going to be opening up schools again. So what are the best things that we can do in the shortest order? And I think that that's kind of been the theme as we've went through, is to try and kind of say what is going to, both time-wise and budget-wise, what are the best ways that we can allocate any dollars or resources that we have in order to mitigate risk inside schools? So there's been a lot of discussion about that. And as for buildings that are not operational yet, we developed a series of checklists. So the idea being that, they were kind of originally written about the idea of schools going back in September. So there's a list of stuff that you can do over the summer, and then there's a list of stuff to do a week before, right? Which is, it also gets into some of the other items like, Legionella control and some of the other topics that we were concerned about. So it's been kind of an evolving discussion. I think overall the experience has been really good. The one thing that I have found is there's a lot of stuff that where we didn't know what we don't know. Now we know what we don't know, but there still is a lot of unknowns that seems to be continually evolving with this.
Makes sense. So then these checklists that you mentioned, is this somewhere where our viewers can go and take a look at this checklist in case they're planning on opening up a school anytime soon?
Yep. If you go to the ASHRAE main website at ashrae.org, there is a COVID resource section. And so that's with Daryl Boyce. And then if you click on the building types, you've got the stuff that all of us have been working on creating. And so you'll take a look. There are tons of presentations and information that we're continually developing and adding to.
Okay.
So that's been a lot of what our focus is to, the idea being that we want to try and get the resources out there because basically, with the timeline and the demands that are on us right now, all of us are smarter than any of us, and we need to try and get this done quickly.
That is very true. So maybe what else we can do is, Jamie, are you still in line here?
Yeah, I'm still here.
Hey, so Jamie, if you don't mind, as we go through these topics, if we can put together maybe an email that we could send at the end to all the attendees with all the links that we talk about over the course of this webinar, that way they don't have to look as we talk and they can focus on the presentation.
Sure. Are you able to just keep track of those links, please?
Sure, I'll try to make a note as well.
Okay, great. And then I can send them out afterwards.
Thanks. Okay, so that was Kyle with this, who is focusing on schools, and we'll switch over to Luke.
Yeah. So when we look at the elements that impact the transmission, actually majority of that is in the droplet, right? The most cases, maybe the most significant amount of cases is in the droplet. So as you probably saw the latest in US CDC regarding office space, they make a position on that in wearing cloth, like a cloth mask, as a requirement for going back to the office. That just came out from CDC a little bit ago. So when we go back to the office, eliminate or minimize the source generation is the key, right? That can be done with smaller amount of people going to the office first, and whoever go to the office, if they follow the US CDC guidelines, they will have to wear a cloth face device. Now, and having said that, and if droplet is one of the key elements for transmission, out of all the measures you can do, one of the way is actually control the relative humidity, and that's the biodefense department come in. They actually did a study, and we did a curve fit. I cannot show you here, but they did a curve fit in general. Relative humidity does matters, and you want to keep the building about 40 to 60% for general good practice. But for virus specifically, actually, they tend to be maybe even the range may be more like 50 to 70% RH is most effective, but 40 to 60% in general for commercial buildings will be good. Now, having said that, a lot of our buildings don't get humidity or humidification in the winter, so that's something in the long term we may want to think about. But that's one of the elements that can impact the droplets, right, because of the humidity. And then on the filtering side, MERV 13, try to up your outside air. And if you have to provide UVC light, now it's not an easy thing to do to provide UVC light effectively in limited space. But those are the three things: outside air, MERV 13 filter, and potentially UVC light. That could be very primary measures we can consider.
The one thing that I might add real quick there is that when it comes to relative humidity, there is also a concern of going too high, in that you can start getting issues with droplet stability. That when you start getting into that 80–90%, the problem is that those small aerosolized particles won't actually evaporate. They'll just kind of float.
I would certainly add to that a concern living in Florida with a little bit of humidity is you'll be growing other things that are way more problematic as well. So, and obviously even the interest and we've had these conversations with a lot of folks as we move back toward, at some point later, move toward winter season. Again, you have to worry about envelope issues if you're going to be pushing RH levels up, and the building really isn't designed for that. When you get to winter conditions and in places like where you are, not so much places where we are. I would add one item just in regards to healthcare facilities, and I'm going to break this kind of into two types. Hospitals, which obviously are occupied and are going to continue to be occupied. Really the issue is they modified their facilities in ventilation in many respects, and as they're easing off on the case counts that they maybe experienced at a peak and now are dropping to lower numbers, what and how they demobilize for the modifications that they made, so that they're doing that right. And then the fact that their ambulatory care facilities, their medical office spaces, which they usually have many, many more than they have hospital spaces, those are going through the same evaluations as probably what Luke has described in regards to the commercial building space, with probably a little greater emphasis and focus on filtration, but more than anything else, just on where they can be smart about upping their ventilation levels. A lot of hospitals went through using their, because of the time of year, afforded them the ability to run airside economizer and once through air systems. You really can't do that as you head into the summer months. And so they all need to kind of evaluate how they can still run decent levels of ventilation, but not compromise humidity control in their facilities.
Yeah, so I'll just jump in here for a second. We have a statement from Eric von Breschoten, and they mentioned that above 60% RH is a baseline for mold growth.
Yeah.
So just
I would agree.
Yeah.
Yeah, it's basically that 40 to 60, that's kind of the golden range. And fortunately, out here on the West Coast, we only have about 200 hours where it's not there. But it is kind of a concern in a lot of spots. And you do have to be careful with it, especially when you're getting into the colder climates, because I find, especially in schools, a lot of maintenance departments have ripped out humidifiers because of the maintenance hassles that they are and the concerns that they'll have growth. So, you know, it's one of those, the information that we have is definitely warrants that they should be used.
Yeah.
Okay, thanks, guys. Max, anything to add here?
Well, I think the original question was about reoccupancy. And I'm head of the residential team. We have the opposite problem. When all those people were leaving the schools and hospitals and commercial buildings, they were going home. So homes were never unoccupied. We have the problem of dealing with people who are not infected and want to stay that way while they shelter in place. And so in the residential section, we very quickly got out guidelines that people could use in their home right away to help minimize their risk. And we're now working on, well, what kind of retrofits can you do to reduce your risk at home? What should you do if you have a family member who is sick? How should you isolate them? What should you do if you have a family member who is particularly sensitive? How should you try to protect them? Those are the things we have in the website now. Multifamily buildings are more complicated. Apartment buildings are more complicated. We have some recommendations, but now we're working on some guidelines for owners, operators, and managers of apartment buildings to say what should they be doing in the operation of their building to try to reduce the spread, particularly from unit to unit. So those are the sorts of things we're doing because we don't have to worry about reoccupancy.
Makes sense. So Kyle, I believe you mentioned at some point the risk of Legionnaire disease. So could we expand on that in various facets and various verticals?
Yeah, so one of the concerns that we had is that if you have systems that have been sitting off for quite a while, they've been kind of sitting up and getting into the warm temperature range, depending on how they're shut off and what the operations is. You could potentially have this chance for a lot of Legionella growth inside the domestic water systems. And also if there was water that like the condensers haven't been drained down, or if they're partially operating, you know, the concern is that when everybody took off and went home, how much thought was really put into it. And so then as part of that checklist, we said, okay, let's recommission those and let's make sure we get that on the list.
Okay, perfect. So the checklist we'll be sending out after, we'll be talking about Legionnaire disease as well. And And just on a separate note, everybody, the questions we cannot answer right now, we will get back to them at the end, time permitting. So that brings us into our next conversation of buildings that are starting up now. A lot of people asked us, hey, my building's opening up in 2 weeks, what can I do? And I think if we break that down, we want to talk about temperature, humidity. I know some of that, Luke mentioned some of the temperature, humidity set points already, but overall, we want to look into the temperature, humidity. We want to look into ventilation, filtration. We want to look into the air side, water side, and BAS. So I'll open the floor again. Kyle, I'll let you take lead here within your vertical segment, and off to you.
Okay, so with schools, basically we're kind of saying, follow ASHRAE standard 55, which is kind of, around that 72 Fahrenheit, give or take, 40 to 60% RH. Usually we're sitting around for ventilation rates. What we've found is that about 6 air changes is about as low as you want to go. And what we said is 6 air changes of clean air. Now, what defines clean air is kind of a little fuzzy. Of course, if you took 100% outside air, but a lot of systems won't be possible of doing that. So how we approached it was that if you don't have outside air, then you could have HEPA air, or you could have UV treated air. But the idea being that this is air that you're reasonably sure is not contaminated. And so we recommended about 6 air changes is the level that we found where the probability of infectivity starts dropping off based on the data that we have. With filtration, we put a lot of research and thought into that, because the question, and undoubtedly more is better. The higher filtration, the better. But where we kind of went and settled is that MERV 13 you can get it in a 2-inch filter, and most existing air handlers that are installed kind of conventionally inside schools, a 2-inch filter is, and the pressure drop of a MERV 13 is something that they can run. Of course, we have a bunch of guidance in our in our presentations there about that, because in some cases it may be straightforward. Like if you have a LEED Gold school, there's a good chance it was designed for MERV 13 filters, even if you're not running it. But in some applications, and if you've got an ECM motor, it's probably okay, or a VFD drive. Except if you've got an old split capacitor, permanent magnet, it's worth some consideration. You also have to look at some fan curves. So those might be the cases where you need to get, more kind of professional engineer involvement, or a specialist. And with the BAS, one of the things that we had been talking a lot about, is that potentially adding pandemic modes of operation, because a lot of the guidance that we're giving kind of goes against the energy use information that we've done in the past. But it is mitigating in the current format. So basically, like for instance, disabling CO2 sensors is something that we say, and just kind of get the outside air volumes up. But that's not necessarily how you have to run all the time. So this is something that we talked about is that you could kind of set it up so inside your building automation system, so then it could kick over and, go to the minimal risk condition.
Right. So is this something ASHRAE would be recommending to manufacturers possibly to make to create a pandemic mode inside the BAS?
Well, this should be an owner's decision, right? It's a risk mitigation strategy. Right. And so if they wanted to put that in, what that looked like, that would be their choice, right? And what that involves, because I would be highly suspect of trying to do it as a blanket package, because it really is something that'll be building specific, at least in my experience. And I think that was for schools, one of the areas that we were quite concerned about was the nursing station, because you potentially have they traditionally locate them right next to the general office. And so if you have, the general office is also usually a big nexus for people exiting the school. And so if you potentially have a sick kid, bringing them to the spot where you're going to get the most traffic probably isn't the best idea. And so we have very specific guidance about recommendations, both in the short term and the long term, in order to handle that.
Right. Makes sense. You also mentioned when we were talking earlier that instead of looking at it as K to 12, you're almost looking at it as K to 5 and 6 to 12. Can you elaborate more on that so everybody else can also get an idea of what you're thinking?
Yeah, like I've, you know, I've got 2 little ones myself, and the one thing that I've kind of concluded is anything underneath 4 feet is a touch surface, and especially with the younger kids, it's going to be virtually impossible to stop that from happening. So then I think that the strategy might have to change a bit there. So then there, you know, it might be that, like, I think for schools, the primary thing is screening people as they come in, try and make sure that we don't get people that are sick inside the building. And, you know, that's kind of going to be one of the key points. I know one of the things that we're looking at in particular is transfer error and how that works. But elementary schools, middle schools, high schools, and post-secondary, they're all schools and they have some things in common, but they all are going to be slightly different in how this actually plays out.
You mentioned MERV 13 filters. We've just got a comment from somebody, and they mentioned that they've read online that ASHRAE is recommending a MERV 14 filter, that a MERV 14 filter is ideal, and lead projects require a MERV 13.
Let me address that.
Okay.
The issue is filtering the 1 micron size droplets. What happens is some of the larger droplets evaporate and they get smaller, and so you wind up with a lot of small ones of the ones that don't settle out quickly. MERV 13 filter is roughly a 50% filter for a 1 micron. Now, if it's in a single zone recirculating system, that's fine because it's going to keep going round and round. It's going to get half of them each time. You're going to do great. You're going to knock the concentration way down. If it's a multi-zone situation where that air may go from the zone where the infection was generated to a different zone, then you want a higher MERV rating, and 14 is about 75% effective for 1 micron filters. So it's a real, it's not very clear on the website. And maybe we should fix that, but MERV 13 is probably the number most of the time, unless you're talking about a multi-zone system where the air mixes, and then you want higher than MERV 13.
Yes, Michael.
I think we need to remember what Kyle said when we started, which is we don't know what we don't know, or there's still a lot that we're working through. We're working with a lot of big healthcare systems, and there's really no anecdotal evidence. And we're dealing with some facilities where maybe they're an 800-bed hospital, and during the peak of the pandemic in New York, say, they had 1,300 patients. They were using library, cafeteria, in addition to every bed in their hospital, patient actual licensed bed locations for these patients. And there's really no evidence that strikes them that this finds its way back to an air handler all the way through all the ductwork, and we won't even get into discussions about a lot of places have plenum returns, but hospitals have, ducted return systems going all the way back through an air handler, through the coil, let alone all the filters, and then circulating back. So it is really tough. It's all of us trying to do the best we can. at the same time, it's trying to strike a balance between what's reasonable, what is adequately cost efficient, and not swinging the pendulum too far, you know, for conditions that are very low grade versus you think of all of the factors. In hospitals, we talk about 3 different controls: administrative, PPE, and then engineering. So administrative is how are you managing and how many people are coming into a space. I think, you know, in commercial facilities, what a lot of the conversation is about is physical distancing and managing how many people, the really just the occupant density in those spaces as we move forward. And at least for a while, you know, you can't do that in a hospital, but you can manage where those people are. And that's what a lot of the focus is around, is dedicating, you know, designating a wing of the hospital or a floor or multiple floors, depending upon what your case count becomes, and dealing with it there. And then people who go into that zone are PPE'd so that you're also managing and not wasting PPE and things like that. So it's really a matter of building a whole holistic strategy around your facilities, no matter what they're used for.
Great. Luke, do you have anything to add to this?
Yeah, for commercial office, sometimes look at the routes that the disease can get transmitted. Droplet is one of them. Aerosol through longer distance in the air. The third path is the surfaces you touch. And maybe the fourth path is through the fecal route. Now for offices, it's interesting. If you look at the US offices, majority of the US offices today, commercial office, they may not have a toilet lid to cover it. Because when you flush the toilet, a plume of liquid will come up, and some of the virus could be resuspended into the air. But our European office, our London office, they all have lid in the toilets. So they can actually close the lid when they flush, so the elements may not that easy to resuspend in the air. So the guideline currently have toilet exhaust on 24/7 because of we don't know after hours who's going to use the toilet and whether those people are asymptomatic or pre-symptomatic. So we do have 24/7 exhaust in the toilet in order to take care of that route. And if you look at some of these studies, right, there are few evidences that the aerosol path was responsible for transmission in a high-rise building. And one of them is Amoy Garden in Hong Kong. And in that incident, actually, is the toilet that is responsible for the transmission. So rather, on top of taking care of the office, the toilet is also an important component to think about because it's a potential path of transmission.
Wow, sounds like toilet specs are about to change. So there's another question that I want to tie into the transmission is the UV and the intensity. So how does that all tie in, and how can we use that within your verticals to kill the viruses?
Well, I know inside schools.
Maybe we'll start with Kyle.
Yeah, I know inside the schools, there's been a lot of discussion about it. We're looking at it in some applications, and including one of the ideas that we've been talking a lot about is the idea of using mobile surface disinfection for, in particular, younger classrooms. They've got these systems that they use for ORs, which basically are a high, like a UV light that runs for 10 minutes and can disinfect all surfaces. The idea being that you use 2 of them, so then you get shadow coverage. So there's been some discussion about those might be a good option or a consideration for schools, because that would allow, especially in the younger grades, to you know, you do your high contact surfaces like your door handles, that sort of thing. But just as a general thing, because, you know, kids are going to touch everything. So that might be a viable strategy. We're also looking at, in some spaces, you know, high air UV, that would be a good option, sometimes inside the air handler. So in general, all the information that we have seems to be that UV is effective. So yeah, it is something that is a means of happening it. I know, Mike, do you have any comments? You've probably got more experience with UV than I
Well,
do.
you know, there's the way it gets used in hospitals is pretty limited, actually. I mean, they'll use it for sterilization of say operating rooms in the way that you're talking about with portable UV systems. You know, very commonly you'll see them in a lot of air handlers, but they're not going to be, you know, they're not going to be effective in care, you know, taking out aerosolized virus. That's really, it's just gonna, if there's anything in there, it's gonna fly past too fast. There needs to be a duration for an effectiveness of a UV light system. What is very common is if you have spaces where you maybe have a limited ability to, or as you're doing physical distancing, you use it as an enhancement measure, say for spaces like a waiting room, which in an emergency department in a hospital, you may still need to use that, even if you're doing some early triaging and then placing people into, you know, kind of specific zones based on what you think you're dealing with that patient. But you still need to cue them in some way. You may use an upper air UV light system so that at least it has some additional air cleaning impact for that type of space. But really that's probably the majority of where we would expect to see it, which is a pretty common and a long-standing measure that facilities have used for you know, for a long time, because there's a lot of germs, viruses, bacteria that can be in public use spaces. I mean, I will also say they've had a number of conversations around using it in homeless centers, you know, facilities that are housing homeless people, which they're trying to do a better job today, and because otherwise it's you know, it's just another risk factor issue to address that population.
So, Michael, since we've still got you in the spotlight, there's another thing I want to tie into this conversation, which is which is long-term facilities. So, what has recently happened here in Ontario is that the government has taken over 7 facilities because they weren't kept up to standards, and there were a lot of COVID outbreaks in those facilities. So, coming from a healthcare perspective, what advice can you give to these facilities based on everything we've talked about or anything we haven't?
Yeah, it's really been probably the most concerning and the most tragic a lot of the times in dealing with it. A lot of the issue is really around administrative controls or the lack of administrative actions. You know, because what really in most cases happens is because of the way the staffing structures are in those facilities, they're interacting with a lot of residents of those facilities. In some cases, they're a staffer that is dealing with multiple facilities, and so they're interacting with just such a wide group of the population. You know, so what I would certainly encourage is that facilities set up dedicated wards for residents that have been that have been struck with the virus, so that they can protect them and then also protect the rest of the population. And that takes specific actions. Also, what we have seen work very effectively is that and this is very hard from a humanistic standpoint, limit even the amount and the number of staff interactions down to just, the main nurse that would do it, and including even that nurse is dedicated to delivering their food, that there's not other aides and other people doing those interactions. It really is a tough situation with those facility types. We can talk about the engineering controls, and there are certain elements of, if you dedicate a ward, then that ward you protectively would put under a negative pressure in relation to the adjoining spaces, units, and so forth. But it's really much more administrative actions and how they can best protect those folks and minimize the interactions that could be risk for them.
Yeah, even the high traffic areas within these facilities, how do you recommend we take care of them?
I think you have to create controls around those things. There should be no high traffic areas. I mean, the challenge is there are certain areas that we could think of,
common rooms, kitchen.
Common rooms. I mean, most, or at least a lot of facilities have really tried to minimize the use of common rooms or created structures toward physical distancing, even in those events. Probably the biggest challenge is around memory care facilities, because you just, the ability to explain what's going on and why it's going on is beyond, beyond the ability for the residents in some cases to understand or really appreciate, the protection measures are for their own needs. And, and unfortunately, a lot of facilities are loath to staff up, really, because in essence, really, to best serve this, you would really need to staff up those facilities at higher levels than they do. And they just, it's an economic decision, unfortunately.
That makes sense. We have another question. Yeah, go ahead.
I want to add to that point is this problem is going to get worse. Today, people above 60 years old worldwide, global population is about 13%. In another 40 to 50 years, global population above 60 years old will be about 23 to 26%. It's almost going to be double in the next few decades. So the next time if the pandemic's going to hit us, not only we're going to stress on the hospital facilities, but also all the old age people will be, or the people above 60 years old will be much bigger issue for the world.
We have some developers in Toronto that are focusing on old age home, retirement home communities, and they're actually building passive homes. Now, how does that tie into all of this with the infiltration and exfiltration?
Well, okay, I'll go for this one. So the passive homes, of course, are initially designed to be very low energy homes. So they're built very tight with a lot of insulation. And none of that affects the epidemic preparedness very well. But you then have to look at the ventilation systems. And some of them are designed with relatively low ventilation rates and not much exhaust in order to keep the energy low. And that may have to be reconsidered. one of the things that you want to do, especially in a home, is have a high degree of recirculating airflow with good filtration, because that's how you're going to keep the concentrations of any unknown viruses low. You can also add UV into the air handler to kill any viruses. That's kind of a high-tech solution, but filtration is definitely a good one. So I'm hoping that the developers will begin to consider epidemic awareness when they're looking at new designs. It's going to use more energy when it's on, but you don't have to have that capacity on all the time. You just have to have it available for when those times are coming up. And I think it won't be too hard to design homes that are like that. Right now, we have to catch up for the homes that aren't, but new design shouldn't be so hard. For example, installing a 4-inch filter grill so that you can put in a high MERV filter that's a low pressure drop and high capacity. It costs almost nothing in a new construction, but kind of hard to do or costs money in existing homes.
Makes sense.
I would add one
Pandemic
thing.
mode.
The senior long-term care facilities have a concept that I believe is called a small home concept. So it's a small number of residents in a pod, and that has proven to be a lot more effective, primarily because of it has a small number of residents in an area and more individualized care in that model. And I think there's going to be a lot more looking at that for senior residential and senior assisted care living as well.
Okay. I would like to circle back to the topic of toilets since we have a question. And the question is, why do we always have toilet exhaust at the ceiling and not at the floor to reduce the flume on flushing? And I would open this up to Luke since he mentioned that.
Thank you. I guess I'm the toilet man. So that actually is a really interesting point in multiple angles. There's been a lot of discussion depending on what your aim is. If your aim is really at aerosol, infectious disease that can go droplet or aerosol, especially the droplets, the idea of having something exhaust at the low level makes sense in the toilet regarding droplets and that sort of element. And maybe more interesting is, what about displacement ventilation and underfloor air distribution? There's a lot of discussion and research on whether that will prolong the droplets from able to resuspend in the air for a longer time and maybe even in the breathing zone. But on the toilet specific, obviously more research will be good, but there's definitely some benefit by locating low to make sure those elements doesn't go up to the breathing zone.
Anything you would like to add to that, Max, within residential buildings and how that could affect, say, a condo building?
Well, so, in terms of an individual unit, you definitely want to close the toilet and use the exhaust fan that's in it to try to capture any particles. You have to think a bit broadly. The particle size spectrum is anywhere from submicron particles to visible size particles. And the particles that you see when you see these demonstrations on TV are normally the visible size ones, or the greater than 50 micron particles that fall down pretty quickly. But there's a lot of particles that are below 10 microns that don't fall down. Once they're in the air, they just float around. And you want to grab them quickly. So, if you have one of those cute Japanese toilets that has built-in exhaust, that's really great. That's going to do that. But once it sort of makes a cloud, it's not going to matter too much for the small particles where you have the exhaust. And the thermal plume from a person is going to tend to make the particles go up. So it's not clear to me that necessarily having a low exhaust is that much better than a high exhaust, unless it's very local. Locality is the key, and that's going to be true regardless of whether it's a home or a commercial building or anything else.
We have a comment come in saying ventilation effectiveness is not highly influenced by location of exhaust grill.
Yeah,
that's a fancier way of saying what I just said.
Yeah, makes sense. I'm just saying that out loud. Okay, so I think we're gonna move on from the operational end of things to construction. So now, because of COVID and social distancing measures that are being taken, one of the very common things is everybody having to wait for construction elevators. So if you arrive on site at 7 a.m., good luck getting up to the mechanical room by 8 o'clock. You gotta wait at least 30 to 60 minutes, 30 on a good day, that is. So that's adding time, and I'm not trying to plant any seeds for the other contractors on the call, but does that eventually lead to increase in construction costs? And it's so hard on site in general, how are you going to socially distance when like 8 people are cramped up in a small trailer, or when it's time for it's deadline and everybody's jammed into the mechanical room trying to work together? How do we avoid this? How does that pan out, and what kind of effects do we see?
Well, I don't think any of us have a crystal ball, but I know that just from my experience over the last while, basically things are taking a little bit longer, and that's just the reality. That's not going to change. One of the things is that I find that we've been able to alleviate a lot of those issues just through discussion and a little bit of planning. For instance, like you said, well, if you get there at 7, then you're not going to get up there by 8. Well, why don't you get some people starting at 5, 6, 7, right?
Yeah.
Like how we've handled it on sites where we had a timeline is that like in a mechanical room where we had, welders, we had electricians, we had controls contractors, all inside the, this room that's smaller than my office, is we did it with shifts. Right. And so one group works from this time to that time, and then they go and they trade out. And so I think that it's moving forward that might be part of it is that we start seeing that, those hours of operation open up a little bit.
Yeah, I would also add what I think it's seen with a lot of subcontractors already was minimizing on-site staffing through pre-assembled systems, whether it was a toilet rack, where they would pre-assemble the whole thing, be able to bring it in, so they would minimize the number of on-site staff needed by doing some things more modularly out in, at their shop. And so forth, along with structured shift setup. We've seen a lot of that, so that they're minimizing their count of people that are on site at any particular time. But it does mean there will. I'm not ever encouraging that construction costs go up, because obviously that deals with us all having to decide, what is considered value engineering and other things to manage costs. But there will, if you have longer or long shifts, you'll probably have some more GC costs over, having staff on site for longer periods of time during a day. And we've seen that even into the evening hours.
Right. I think the other question that we need to ask is what's the dosage and time, right? So it's two elements to get you infected. One is the dosage, the other one is time. So the dosage is not going to be one virus. It's going to be closer to 1,000 of virus before you get sick. So when you think about it that way, and the dosage has a lot to do with whether you're screaming, singing, breathing, all that, right? If the people are just breathing inside the elevator, the dosage is really estimated to be low. I guess one paper roughly estimated in the double digits range. So the point is, it does take a while if everybody is just breathing inside the elevator and they are wearing some sort of PPE or cloth mask or whatever. Now, but if one person sneezes in the elevator, then it's a very different story. So CDC guideline in the past has the prolonged period of exposure is 10 minutes. Right now, they update it to prolonged period of exposure is 15 minutes. So the point is, depending on what exactly people are doing inside the elevator, if you are not talking and breathing, chances are the dosage will be low. But if you have one person sneeze, that is problematic. But nevertheless, the prolonged period of exposure is about 10 to 15 minutes from CDC guideline.
Thanks, Luke. So we'll move on to design and future proofing. So the question is, how will COVID-19 change how buildings are designed moving forward? And how to future-proof buildings against airborne diseases? And we'll start again with Kyle.
Yeah, well, this is something that we've been talking a lot about. In some areas, it's very obvious, like, for instance, like nursing stations. Well, yeah, here's some things that you can do and potentially some of the layouts. One of the things that I think came up was that we have to put a lot more thought into how we're treating transfer air. Because quite often, air is supplied to the classrooms and is transferred to the hallway and then returned. And so then how does that look? It would be better off if we weren't kind of basically creating a potentially contaminated space that everyone's going to be walking through. So maybe there's some things there. There's a lot of discussion about DOAs, right? And then, humidification and dehumidification, because DOAs, and the one thing that when we looked at it is DOAs are good because you've got 100% clean air. However, if you go into some areas, like, depending on what your climatic conditions are, like, it doesn't make as much sense. With the way that kind of a lot of systems that are designed on the West Coast, there's a lot of economizer use. And so we use a lot higher air volume. But the thing is like, for instance, right now with the schools going back in, pretty much all the schools are just going 100% outside air with about 3 times what the DOA's kind of equivalent would be. So I think that there's going to be some stuff that it'll be kind of regionally, environmentally based. There's also going to be a lot of different kind of strategies employed. So, I know that's something that we're discussing a lot, and then, I think we seem to be kind of coming to consensus about some points on when it comes to, use of UVC, enhanced filtration in some areas, and also kind of the pandemic versus non-pandemic operation.
So one of the limitations of DOAs is the ACH, the air changes per hour. Would you comment on that?
Yeah, well, it depends on your space, right? Except I think one of the challenges becomes that if you've got a DOA systems that's just serving a single room, then or versus a whole wing, right? What I would think is that something that might be viable if you've got a DOAs is that you may be able to do enhanced room level filtration. So you could have fan HEPAs inside the individual rooms. You could, you could make up the difference in air changes in different ways. But the idea being that you're not recirculating and transferring as much air.
Right. Okay. I would like to switch up to Luke now. Hey, Luke, would you care to share what your thoughts are on the commercial side?
Yeah, just the question just now regarding DOAs and maybe VAV system with compared to DOAs, both on, let's say both have minimum outside air, right? Let's say it's the DOAs is either a fan coil or VRF or chill beam, which is typical in a lot of the commercial office reactor systems. Compare VAV system with minimum outside air, identical amount of outside air. Now, it's not clear to me that DOA is going to, in the long run, be the winner. And here's why. Because, yes, the DOA is going to bring fresh air to the space, but inside the space, the amount of circulation is, even if you have a fan coil, you may have a MERV 8 filter in the back of the fan coil. If you have VRF, depending on what types, you may not even have a good filter. But on the VAV side, same amount of outside air. But if you are recirculating, typical is about 6 air change in an office, about 1 CFM per square foot. You are recirculating all those air through a MERV 13 filter. So in the long run, it's possible that with times goes by, you could have actually cleaner air because everything is circulating 6 air change through a MERV 13 compared to a dedicated outdoor air system that may or may not have good filter locally. So that's something to think about. The other point to think about is we really need to have more data about how this thing is aerosol or not. It's, we just don't hear, like, for example, somebody went to Costco or one of those, big box store, and then all of a sudden everybody got sick. We just didn't hear this sort of evidence or data. So more research needs to study how much of these elements or material actually get aerosol. Do they find it in the AHU? How much? Is the dosage strong enough to get people infected?
See. And how about from the design perspective? How do you see it being in the future?
Definitely, I think we got to think about not just one thing, right? I mean, currently we worry about pandemic, but if you look into the future, the top three health threats going to derail our globe is actually climate change, and then chronic diseases, and then pandemic. Those are from World Health Organization. So you think about that holistically. There are measures that are the common multiples for all those elements and also good for normal times. For example, MERV 13 filter. Now, to change MERV 13 filter, if you have a 20,000 CFM unit, it's roughly about several $100 in US, several $100. But if you have to add a UVC light, it will be $10,000 to $20,000 in our pricing. So I think you want to look for the measures that are good for normal times, good for also emergency time, and not just emergency time of pandemic, but forward-looking into what are the elements that can derail our economy and try to have these high-level elements that can do that. And for example, MERV 13 is an inexpensive way to able to achieve quite a bit of that.
Yeah, let me just add on to what Luke just said, and that is, if we're looking at sort of what affects people's health, particles are probably the #1 thing. They affect almost every form of major disease, from heart to lung. Even Alzheimer's and diabetes have a factor that's related to small particles. So adding increased filtration is a no regrets policy that's going to help everything, even not just the epidemic issues. So that's really where you want to go first, because it's by far the cheapest way to control aerosols and therefore improve health, and has the COVID benefits.
Thanks, Max. We'll move over to Michael.
And I think, Max, you hit a very important point. You know, when we were starting to assess and figure out, well, what are those issues? When you looked at the places where PM 2.5 were highest were the places where the fatality rates also seemed to be highest. And you have to imagine those are corresponding, related factors in those things. From a standpoint of healthcare facilities, primarily, I would say there's two things that will probably drive the conversations from a design perspective going down the road. One is what a lot of facilities have been incorporating into the design of their facilities, which is acuity adaptable rooms. So a room that, although is structured maybe perhaps as a regular patient room, it has a lot more of the infrastructure that can allow it to serve also for ICU level care. And there is a lot of both medical gases and electrical infrastructure in addition to the mechanical systems, whether that is something that, as Kyle describes, doing that with a pandemic mode. I think part of the challenge with a pandemic mode in a healthcare facility is, this virus and pandemic is slightly different from, say, the SARS one that you guys dealt with, that a lot of other places dealt with. So I think that adaptability is really gonna be key, and even the matter of more easily being able to program or adjust the systems, because I think a lot of the conversation was around that. Those are things I think that will be a lot. And I think segregating the HVAC system, even at hospitals, there's a lot of conversation about having these systems serve a lot of big square footage because of efficiency of doing it. But it unfortunately restricts the ability to flexibly do some of the things that we would say are the owners and the healthcare facilities realize they want to do now.
Yeah, actually, that's something that we talked about a lot in schools, is that, kind of that individual unit or localized units, that approach basically, you have a unit that's serving just the one classroom, and then it can be exhausted, and you can do heat recovery there and centralize your heat recovery systems. There's some definite efficiencies there. Of course, one of the concerns, and I know there's actually some people on the ETF are looking at re-entrainment as well, about, if you are exhausting huge amounts of air out of the building, how much of that is just getting sucked back into the next room, right? Yeah. So it creates some challenges, and because you don't want to run 16 miles of ductwork, but
yeah.
Michael, one of the comments that has come up is medical staff wearing full PPE are still getting infected at low rates, and long-term exposure at low concentrations of the virus can be an issue. Could you comment on that?
I can't point to, I don't know that anybody can specifically point to why and how is that happening. I think, like anything else, there's going to be a mix of factors. One is going to be how is their PPE fit tested, and are they not reusing it as much? Because I think part of the concern, and And I think something that everybody needs to appreciate is that an N95 is an electrostatically charged filter. So over the course of time, it becomes less effective. If you reuse it with the filter as it's provided by the manufacturer, over the course of time and use, it becomes a lot less than 95% filtration. And that is a real factor if they're using them for extended periods because they're rationing them or whatnot. The other is that you know, the droplets that Luke talked about are droplets that when you're interacting with those patients, especially if you're doing things that are involved with patients that are creating aerosol generating procedures, you're going to collect that stuff on your gear. And so when you're taking your gear off, the CDC has, and I'm sure the Canadian standards have similar structured protocols for how you take your gear off safely, so that you don't contaminate yourself. And then in that you know, and so those things happen, unfortunately. You know, we certainly have a reasonable amount of concern about providing safe environments for the healthcare workers, but they are the front lines, and they're interacting with those patients every single day. I noticed there was a comment specific about ventilators. I think, you know, two things in regards to patients on ventilators that make them probably less or less of a concern to deal with than other patient types. One is typically ventilators and an intubated patient, their breathing is, the ventilator itself incorporates a HEPA filtration discharge. So the air coming out from them breathing, being assisted breathing, should be actually safer than them breathing on their own. And about 60 to 70%, I think, at least as far as I'd heard, about 60% of patients in an ICU ended up on a ventilator. And so the patients that weren't on a ventilator are probably more apt to be, should be treated with a level of concern, and probably at that point in a neutral or negative pressure room. And then secondly, from what we have heard from research, people actually do more viral shedding before they're either pre-symptomatic or just starting to have symptoms, but aren't in a hospital. You know, and so those are other factors to think about.
I think there's probably also a component of fatigue, right? That it's, you know, what you have to realize is like my wife's a nurse, and you know, in order to make sure that we're not bringing it home, then we've got a whole series of steps that we take. However, the thing is that, you know, all it takes is one day where you just kind of itched your face, or you just, you know, like it. And I think that is part of it is that, you know what, you can follow everything, but all it takes is just one mistake.
Yeah.
And so, you know, this is where I think it's the best solution is just trying to mitigate it. And, you know, yes, surface contamination is an issue, right? And you can you can do everything properly, but just, you know, a small mistake is all it takes. So it's hard to avoid that.
Yeah.
That's very true. So at this point in time, I would like to move on to the questions that have been coming in. Just give me one quick second here. All right. So let's start here. South Korea released a room map of transmission in a call center a few weeks back, showing the pattern seeming to skip some of the room. I'd once heard zones under an intake grading have higher rates of droplets precipitating out. Is there any indication droplets are precipitating out below gratings disproportionately? Or is that a poor understanding and this incident is just coincidence?
Well, I think that they're talking about exhaust, like exhaust intakes. inside the room. Except I think there what it is it's may have to do with air pattern. So with the, like one of the things we talked about inside classrooms is that, typically you'd have like the teacher standing, at one side of the room, but we said, where are the grills? Are we blowing the air, potentially contaminated air into somebody, or, like what is the flow direction? So I don't think it has to do with, it would have so much to do about condensation. I think it has to do with like the airflow direction, right? Because any aerosolized droplets, if that is, or even the larger droplets that might carry farther, they will kind of tend to follow the airflow pattern. Except as Max was talking about, the ideal gas distribution, they're going to go everywhere anyways, but they will kind of flow that direction.
Right. Okay. So the next one over is most systems are designed for mixing in the indoor spaces to ensure outdoor air is well distributed to the occupants. This is typical for ceiling supply air and ceiling plenum returns. On this basis, social distancing indoors does not appear to work very well. So are airflows in rooms being reviewed for current and future designs?
I think we're actually mixing two things. The social distancing is more about, if you want to think about it, the ballistic transport of the larger droplets. Somebody sneezes and there's a big cloud. You want to be far enough away that you don't get hit by this. The larger droplets fall off. The smaller droplets are a cloud, and that cloud is going to disperse and mix, and mixing is actually good because the more the air moves, the more the smaller particles will get deposited on surfaces and get out of the air where they could land in your mouth or nose or whatever. So you have to kind of keep in mind which end you're talking about. You want actually a lot of mixing within a single zone, but not between zones. And you want the masks and social distancing to keep the larger particles from flying and hitting you after somebody coughs, breathes, sneezes, or sings in your general direction.
Great. So there's a couple questions about dental clinics. I'll combine them. So one of them is any guidelines for reopening dental clinics? And the other one is, in a dental clinic, they have been providing directions for possible portable HEPA units. The units will blow filtered air in an upward direction. As a result, this may cause the mixing of aerosols during the cleaning of teeth. To provide air changes, is there guidelines that the units remain off during the use of aerosols, or do they continue to run the units?
So the Epidemic Task Force has a dental group working on some of these conversations right now. A couple things to think about, or that I would certainly encourage that the folks that are asking the questions to think about. One is, like ultrasonic cleaners are definitely a source of aerosolization. So, what are the practices that people are taking, and how do they not do those practices to minimize the aerosolization in the first place? The second is, how can you run continuous suction? Source control. Source control is a wonderful thing. And the concern in some cases, especially for smaller practices, is the ability of suction to run continuously, because it's not sized for it, or it'll overheat, or who knows what issues may arise with that. And then the matter of putting a recirculating HEPA machine in a room, apart from the noise factor, which I'm in most cases there's going to be some noise factor. It has both a helpful effect and a palliative effect, and those are both important. Palliative just meaning it provides a level of reassurance. probably would provide all of us a level of reassurance if we were going to our dentist, which I'm sure all of us have generally pushed off, which is one of the more welcome things that you could push off for a little while. But you know, the concern is that, you know, most are open days. You know, it's just there's just a host of factors in those kinds of facility types. You know, but there are certain things, especially like dental surgery, where you really do need to approach it from a standpoint of source control as best you can.
Well, I'm just thinking that, you know, if it's doing dental work, yeah, it's, they don't need to be, you know, if they can just, instead of using the sonic descaler, if they just use the regular one. However, there's also, I might think that exhaust would be better. So then you're drawing the aerosol, potential aerosol into the HEPA filter as opposed to blowing it from.
From what? From the HEPA filter? I mean, it's HEPA filtered, so you know.
Yeah, well, it's
it shouldn't be an issue.
The application that I was thinking of is because I've seen this in some dental offices out here, where they've put a HEPA filter kind of behind where the patient's head would be.
Yeah.
And so the idea being that any aerosol that's generated will immediately go back, so then it's not spreading out to the room and not spreading to the person that is working on them as well.
The
right?
person
So
is
it's
working
source
on
control.
being in front or on one side, and then the HEPA unit being on the other side.
Yeah.
Yeah, I would agree, absolutely.
Okay, maybe we'll direct the next question to Luke. And no, Luke, this is not about toilets. So how is a mall different from a box store? Oh, I think we just lost Luke.
Uh-oh.
Uh-oh. Maybe he didn't want to answer the question because he thought it was about toilets. Okay, we'll move. Any one of you can answer it. How is a mall different from a box store regarding COVID and HVAC?
Well, I guess in general, most malls usually, or at least the ones that I've been used to, they tend to run kind of positive pressure in the common areas and then negative inside the individual stores. And so then there, the thing is, you know, if you were working like as opposed to a box store, which is completely independent, there it's just a giant, you know, it's a giant mixing box. But inside a mall, there would tend to be, you know, if someone was sick inside the general areas, that would then, you know, there's the from an aerosol standpoint, but there's also touch surfaces as well. So they are different in kind of how I would approach them.
I just add the general principle that anytime we're talking about multi-zone buildings, you want to use the smoke control principles of positively pressurizing the common spaces relative to the individual spaces, so that if there is an infection in the individual space, it does not go out into the common space and create that. This is true for apartment buildings, for commercial buildings, hospitals. It's just a good general principle.
Perfect, thank you. So the next one over is ASHRAE 170 recommends ICUs neutral pressure at 6 air changes per hour. Since COVID patients may be put on a ventilator, this procedure is the most dangerous time for potential aerosols from the COVID patient being intubated. Should changes be considered to add an anti-room negative to both ICUs and negative to the corridor? In Canada, the CSA Z317 standard requires ICUs be positive.
Yeah, and I answered the first part of that. The second part of that, the matter of the ICU rooms being positive, you know, the ASHRAE 170 is I can tell you actually, but there's my handy dandy small version, but I'm pretty sure there's no requirement for ICU room any longer. And that's correct. so the issue may be more a matter of defining if you're going to house a COVID patient, if you have the onesie twosie in count, then it'd be a matter of probably putting them in your airborne infectious isolation room just to keep them protected from everybody else. And then the rest of the rooms would be fine as being positive. If you got to expanded basis where you had a lot larger case count there, then I think you would probably want to look at dedicating one of your ICU areas to COVID use and probably making all of those rooms neutral, and then the suite of rooms negative to any adjoining spaces or adjoining critical care units.
I know there's also been some discussion about making potentially temporary airborne isolation rooms or rooms that can be flipped over.
Yeah, you have to be really cautious about that because a true airborne infectious isolation room is high air changes, higher than a regular patient room, and that's a big issue. It's negative pressure, and all the air is exhausted directly to outdoors. It's not shared with anything else. It's directly, and so that's a lot of infrastructure. I think, when we talked about designing, for the future, where maybe you did one or two of those rooms on a patient floor, maybe you would consider doubling that amount and setting it at the end of the corridor so that you had that ability to have more flexibility about that. But yeah, you do need a true airborne infectious isolation room is a costly item forever. Really is the challenge in that decision making.
Thanks, Michael. The next one over is regarding displacement / UFAD ventilation options in COVID. The respiratory droplets are evaporating very quickly. Most won't reach the ground, hence they float. Air distribution systems that create stratified levels which can store small particles until they are exhausted, or UVGI'd at the ceiling level are potentially better. This may not have been a question, it may have been a statement. So, do you agree with that?
Yeah, high level, high air UV seems to work well, and with displacement, I would say that makes sense.
No, you don't need high room UV with displacement because it's never going back down again. If you have true displacement ventilation, which nobody ever does, but if you have true displacement ventilation, it's actually pretty good because everybody's in their own plume. The plume goes up and it's exhausted above the breathing level. High room UV works pretty well in a mixed situation where the air is going up and coming down again and going up, coming down again, and that's what kills the viruses. But since displacement ventilation rarely works, high room UV is probably okay because it's really a mixed situation.
Yeah, and especially in cold climates where the roof might be cold.
Great. Next one over is most buildings I come across in the small to medium market might be sort of doing one of the many things to reduce the risk of transmission during an epidemic. Is there a standard that will come out to label which buildings are designed and are operated to provide a safe environment for occupants?
Well, it's easy enough to answer that question. There's going to be no standards that come out of ASHRAE quick enough to do that.
Okay. I've read that foot traffic control is an effective contagion control. If buildings are to be designed to alter how people move and gather to reduce face-to-face contact, how will that affect ventilation design to reduce particle exchange across these paths? Who would like to take that one?
That's a Luke question.
And Luke's back.
Sorry, I got cut off. Can you repeat the question again?
Yeah, I've read that foot traffic control is an effective contagion control. If buildings are to be designed to alter how people move and gather to reduce face-to-face contact, how will that affect ventilation design to reduce particle exchange across these paths?
Wow, that's not an easy question. That's something to definitely think about. But, you know, this may be a, maybe, you know, in the commercial office right now, when we go back to work, we're gonna have one-way traffic flow. And maybe more interesting is how do you deal with that in the stairwell? Because right now in the commercial office, what we recommend people do is if you have two stairwell, one is going up, one is going down. So that might be some consideration on thinking about how the airflow doesn't blow consistently on one person and cascading onto the others. But that, I think that dimension needs to be reviewed and studied at a more specific level. Is I don't know we know all the answer to that yet.
Fair enough. I'll move on to the next one, keeping in consideration our timelines. Any new guidelines to AIQ expectations?
Well, I think it's all being looked at, but
Yeah.
as opposed to like, you know, is this going to change what ASHRAE 62 says? Probably, inevitably, to some degree. But, you know, we kind of need to have the data to back it up. Right now, we're saying, okay, you know, like even, I think it's one of the whole things of like even the whole discussion about aerosols, how much of a role is that? We don't know. We know that surfaces are a thing, and I know that for me, that's been one of the big learning experiences of this is realizing that a lot of like the whole 6-foot guidance that came from like some studies done in the early 30s. And so what's the actual data? And like with these modes of transfer, these modes of infection, and then even just like the modes of virus deactivation inside aerosolized droplets. There's a ton of research going on. And so what I would say is that right now we're kind of following best guidance based on the information that we have. And moving forward, as we have more research, we'll be able to more definitively comment on it. But at this point, we're just saying,
stay tuned.
Yeah. Well, and here's what we can do right now with the information we have.
Fair enough. So now that higher efficiency is such a concern, has there been any discussion to specify MERV A discharge efficiencies?
That's a hot
I feel like
button,
Michael, you're going to say
topic.
something.
I'm not going to touch it.
Would you like to contribute?
It is a, you know, as anything else, it's a caveat emptor, buyer beware. Understand what you're buying.
Yeah, I think like MERV 8, it's one of those things of you know, I think a lot of this is it's a risk tolerance aspect. You know, and inevitably, MERV 13 is better. MERV 17 would be better than that. You know, the whole thing is, except will you ever get to 0? No. But where is that risk tolerance, right? And so
right,
I think
but there's one important issue, and that if you're talking about MERV 8 or below, it is not filtering any of the particles that affect health. It's only about keeping ducts and coils clean. As soon as you get above that, you're starting to remove the particles that affect health. And from sort of 10 to 12, you're getting the PM 2.5, the biggest of the particles that affect health. And as soon as you get to 13 to 16, you're affecting the 1 micron size particles. Now, a virus, the SARS-CoV-2 virus, is about 1/10 of a micron in size, but it's never naked. So it's always in size of particle that's about 1/2 micron in size or bigger. HEPA filters will get you even better, and you might need that in some circumstances. But the MERV 13, 14, 15, 16 is probably going to do everything you need to do in any normal situation.
Okay. What are the specific risks associated with low humidity and virus transmission?
So there are two issues here. One is that mucous membranes at low humidity are much more susceptible to absorbing viruses and bacteria. So if you are breathing in low humidity air, you have a higher risk of taking in the virus that we care about. So you don't want to be in too low a humidity air. Second thing is that the aqueous aerosol particles will get smaller faster the lower humid the air is, which means they'll stay airborne longer and they'll be more concentrated in whatever viruses they have in them. So they'll pack a bigger punch. Now, those are sort of the direct health sides, but you have to look at humidity from the building point of view as well. If you take a typical Chicago apartment and try to do 40, 50% humidity in the winter, the mold is what's going to kill you, not the SARS virus. So that just doesn't work. On the other hand, in Orlando, 50% humidity is not going to be a big problem indoors because the outdoor temperatures are quite high. So you have to look at the whole humidity design from the building's point of view, as well as from the COVID point of view.
Thank you. So the next one is, would there be any certain timeline to open up the HVAC systems in commercial buildings / shopping malls before people enter them due to the mold accumulated and its influence on people's health?
Well, there's a startup guideline in ASHRAE that talk about that. I think first you need to find out whether there are elements like that in the ductwork, and chances are, depending on where you are, they may vary. But for the minimum, there is a flush out period, not only just in the startup, but also in the before you occupy a building and after you occupy a building. Some of the rule of thumbs we've been looking at, for example, is roughly 3 air change of outside air will eliminate about 95% of the contaminant inside the space. That's not specific to ductwork, that's more to the space. Regarding the ductwork issue, while there's no, unless you find out there, we should inspect to make sure there's no mold growth or anything like that happen inside the space or in the ductwork. But without those elements, then roughly about 3 air change will eliminate 95% of the contaminants. And that may be something you want to consider, not only to start up the building, but also during when you occupy the building. That's something you do before work and after work.
Thanks, Luke. And we've got 2 more questions before we wrap this up. And the second last question is, should we be designing for COVID-19 or using highly likely characteristics of future pandemics, or to limit seasonal flu spread? So COVID or seasonal flu spread?
Of course, both.
It's not hard. What helps for COVID helps for flu in general.
Right. Well, the other thing is you got to figure out, now, if you look at where the population is going, right? World Health Organization predict the world will peak at 9.4 billion people in 2070. And there will be a lot more international travel because of the sheer growth of the population and the more globalization of the world. So chances are pandemic is not going to go away. It may come in a different form. Some of you probably heard Bill Gates said 50% of anybody's lifetime may run into a pandemic. So chances are it may come again.
Makes
But not in
sense.
our
And
lifetime.
this time around, we're going to be ready for it.
Well, I think that,
Well,
that's just,
contradicting views here, Max.
I'm older.
I think, you know, one of the things that it has done is that I think there was a lot of research and a lot of science and effort that went into it back in the, you know, 20s and 30s. And then kind of we said, okay, it's good enough. That's a problem from a long time ago. And so I think one of the things is coming out of this, we're going to have a lot more information about how these actual modes work. And that can kind of help us with our building design to try and mitigate it. So I think like with a lot of the same things that we've learned and strategies that are put into place, like, you know, why is it that when we sent kids to school, we kind of went, oh, well, yeah, my kid started school, so he's going to be sick for 3 months, right? And this is something that we've all just come to expect, except one of the questions that I've always had is why? Why is just this perpetual state of runny noses and coughing? Do we just consider this fine? So if we can learn from this and try and mitigate that and just create healthier environments, I think we're all better served. So is it COVID related? Yes. Is it COVID specific? I think a lot of the same lessons hold true, you know?
Makes sense. So the last question we have here is, do air curtains present any dangers that should be considered with regards to possibly disturbing settled droplets?
By and large, aqueous droplets don't unsettle. And they're not dry particles. They're stuck pretty good. So you would need a huge air velocity on the particle to kind of get it unstuck, which would probably evaporate it anyway. In general, air motion is a good thing because it causes the particles to deposit on the surfaces. But I haven't seen any data on air curtains, so I don't know this for sure.
Fair enough. And that wraps up all the questions that came through, all the comments that came through. And that also wraps up our panel discussion today. So I would like to say thank you, Kyle, Michael, Max, Luke, Kara, Jamie, for organizing this, anybody else who was behind the scenes to put this together. And this concludes 2019-2020 ASHRAE year, and 2020-2021 starts in July. So we'll see you again as we put on more events. And thank you all for joining. Have a good day, and we'll see you soon.
Bye, everybody.
Thank you, Abby.
Thank you. Bye.
Thanks, guys. Bye.
Bye.